Hello everyone. In this video, I'm going to talk about magnetic quantum number and its relationship to principal quantum number and angular momentum number. We said that principal quantum number denoted by n can be 1. But when that happens, the next thing we should know is that when principal quantum number is equal to 1, angular momentum number is going to be L less than or greater than n minus 1. And we said when that happens, I'm going to have a situation whereby L is going to be 1 minus 1. So L is equal to 0. Now, magnetic quantum number, let me write it somewhere here. Magnetic quantum number now works differently. It gives us the orientation. It gives us the orientation, and it divides subshells into orbitals. So if that's the case, when I'm having my principal quantum number as n, the angular momentum number is going to be 0. For that reason, I know very well I'm referring to s orbital. So when I'm referring to s orbital, my magnetic quantum number, which is always denoted by letter small m, small l, will show me that if L is 0, I'm going to have m0, which is still the same as 0. So it means I'm still coming back to the s orbital. When that happens, now what is the orientation of that given orbital? So when I'm having s orbital, my ml is going to be 0. And therefore, the only thing I'm going to draw based on the orientation of the orbital is just an orbital of s. That's when my principal quantum number is 1 and L is 0. So for that matter, we can get a relationship. So it means that ML, which is the magnetic quantum number, it can range between negative L to ML positive L. Next, when I want my angular momentum number to be 1, and I want my angular momentum number to be 1, what is going to happen? We'll realize that my N must be what? So imagine a situation whereby when N, which is the principal quantum number, is equal to 2. What did we say? We said when N is 2, L is going to be N minus 1. So L is going to be 2 minus 1. And lastly, L is going to be 1. If that's the case, I can honestly say that here I'm dealing with P orbital. Because when L is equal to 1, my ML, which is magnetic quantum number, is going to be minus 1, 0, 1. So if that's the case, I'm dealing with P orbital here because I'm having 3 shells. So I'm going to draw my P orbital here. The first one, the second one, and the third one. For this one, ML is going to be negative 1. Here it's going to be 0. Here it's going to be 1. For this reason, the orbital shapes are 3. If I have something like that, because I'm supposed to be having the 3 of them. This one, this one, and this one. And we know very well that in P orbitals are always divided into 3. 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . 3 . We have the p, x, the py, and the pz. Because I'm dealing with the angular momentum number also here that tells us the shape, I'm supposed to tell you the shape. So whenever I'm having a px, so it means that the p orbitals are oriented based on the magnetic quantum number, are oriented along the x-axis. So I'm going to have a sketch. I'm going to have a sketch, not drawn to scale. So I'm going to have x and y. So on the px, my dumbbell, because the p orbitals are dumbbell shape, are going to be oriented along the x-axis. Let me create enough space here so that we can do neat work. The next one is a p, y, and after drawing the Cartesian plane, I'm going to have x, and this is y, because magnetic quantum number is supposed to tell us the orientation, how the orbital is oriented, and the angular momentum number tells us the shape. So based on angular momentum number, I know very well that I'm dealing with the p orbital, and the magnetic quantum number is telling me that the orientation is now along the y-axis. And now I'm simply going to draw a dumbbell along y-axis, and that's my py. Next is a pz. It's called z, and the same is going to happen. I'm going to draw an Cartesian plane. This is my y, this is my x, and z is going to be along that line. Sorry, it's just a sketch, so it must be along the z. This one now is going to be my z axis. So that's where the orientation of my dumbbell is going to face, along the z axis. So the key thing that we should know is that however much the principal quantum number n is telling me the shell I'm dealing with, angular momentum number tells me the shape of that given orbital. Now, magnetic quantum number tells me the orientation. So when I'm having a px, the orbitals are oriented along x-axis. Oriented along x-axis. When I'm having a py, they are oriented along y axis. When I'm having a pz, the orbital is oriented along the z axis. So, lastly, when I want to be dealing with the d orbital, if I want to deal with d orbital, sorry, I'm just organizing my page for it to appear better. When dealing with the d orbitals, I know very well that L is supposed to be 2. So meaning I'm supposed to have principal quantum number n being 3. So angular momentum number, which is L, being greater than or less than n minus 1, I'm going to have L equal to 3 minus 1. And at the end of the day, I'll have my 2. So the magnetic quantum number, ML, is supposed to be giving me an orientation of minus L, ML, L. So based on this data, I know very well that I'm going to have an orientation in which now I'll be dealing with the d orbital. And the d orbital has 5 orbitals. 1, 2, 3, 4, 5. And now I know very well that the magnetic quantum number here is minus 2, minus 1, 0, 1, and 2 based on this formula. So because the angular momentum number was 2, so I'm supposed to be having 2 as my last value. So I'm going to have minus 2, minus 1, 0, 1, and 2 lastly. So these are the orbitals that I have within the d. When I have that, these are the places where electrons are going to be found. These are the places where electrons are going to be found. Thank you very much. That was magnetic quantum number, and I've even gone ahead and explained to you the relationship between magnetic quantum number, angular momentum number, and principal quantum number. Have a wonderful